Intro. Hello everyone, and welcome back to our channel. In today's video, we're diving deep into an exciting topic that is transforming the way businesses and organizations operate, building an end-to-end automated AI workflow for real-time data processing and insights. As data continues to explode in volume and variety, the ability to harness its power through automation and artificial intelligence has never been more critical. Whether you're a data scientist, a business analyst, or just a tech enthusiast, this video is packed with valuable insights to help you understand how to create a seamless and efficient AI workflow that can process data in real time and deliver actionable insights. What is an end-to-end AI workflow? Before we get into the nitty-gritty of building an automated AI workflow, let's first clarify what we mean by end-to-end. An end-to-end AI workflow encompasses all the stages involved in processing data and generating insights, from data collection and pre-processing to model training, deployment, and monitoring. Think of it as a comprehensive pipeline where each stage is interconnected and optimized for efficiency. In this workflow, we typically start with data ingestion, where raw data is collected from various sources. This is followed by data pre-processing, which prepares the data for analysis. Next comes feature engineering, where we extract relevant features from the data to improve the performance of our machine learning models. After that, we train our models and evaluate their performance. Once we have a model that meets our criteria, we deploy it in a production environment. Finally, we continuously monitor the model's performance and make adjustments as needed. Why real-time data processing? Now, you might wonder why real-time data processing has become such a hot topic in recent years. The answer lies in the fast-paced world we live in. Organizations today are inundated with data from various sources, including social media, IoT devices, transactional systems, and more. The ability to process this data in real time allows businesses to gain immediate insights and make data-driven decisions that can significantly impact their operations. Real-time data processing enables organizations to respond swiftly to changing market conditions, customer preferences, and operational challenges. For instance, a retail company can use real-time analytics to optimize inventory management, ensuring they have the right products available at the right time. Similarly, a financial institution can detect fraud as it happens, minimizing losses and protecting their customers. Steps to build an end-to-end automated AI workflow. Let's break down the process of building an end-to-end automated AI workflow into manageable steps. We'll walk you through each stage, discussing the tools and technologies you can use, along with some best practices. 1. Data ingestion. The first step in our workflow is data ingestion. This is the phase where you gather data from various sources. Data can come from databases, APIs, external services, or streaming platforms. In today's environment, popular tools for data ingestion include Apache Kafka, Apache NiFi, and AWS Kinesis. When designing your data ingestion system, consider the volume and velocity of your data. For real-time processing, streaming platforms like Apache Kafka are often preferred since they can handle high throughput and low latency. Make sure to set up a robust data pipeline that can manage and transform incoming data as needed. 2. Data pre-processing. Once you have ingested your data, the next step is pre-processing. Raw data is often messy and unstructured, so cleaning and transforming it is crucial. This may involve handling missing values, removing duplicates, normalizing data formats, and filtering out irrelevant information. Tools like Apache Spark and Pandas in Python are indispensable for this stage. You can create ETL, extract, transform, load processes that automate data cleaning tasks, making it easier to prepare your data for analysis. Remember, the quality of your data directly impacts the performance of your AI models, so don't skip this step. 3. Feature engineering. With clean data in hand, we move on to feature engineering. This is where you extract relevant features that will help your machine learning algorithms perform better. Feature engineering can involve creating new variables from existing ones, transforming categorical data into numerical formats, or scaling data to improve model accuracy. For example, if you're working with time series data, you might want to create features like moving averages, lags, or differences. Tools like feature tools or even custom Python scripts can help automate this process. The key here is to experiment and iterate, as good features can significantly improve your model's predictive power. 4. Model training. Now that we have our features ready, it's time to train our machine learning models. This stage involves selecting the appropriate algorithm and tuning hyperparameters to optimize performance. Popular libraries like scikit-learn, TensorFlow, and PyTorch offer a wide variety of algorithms that you can leverage for your specific use case. When training your models, don't forget to split your data into training, validation, and test sets. Use cross-validation to ensure that your model generalizes well to unseen data. This is particularly important in real-time applications, as your model will be making predictions based on fresh data. 5. Deployment. Once you've trained a model that meets your performance criteria, the next step is deployment. This is where you take your model from the development environment and make it accessible for real-time predictions. There are various options for deploying models, including cloud platforms like AWS SageMaker, Google Cloud AI Platform, or using containers with Docker and Kubernetes. When deploying your model, consider the latency requirements of your application. For real-time predictions, you want to ensure that your model can respond quickly to incoming requests. Implementing a REST API or using serverless architectures can help you achieve this. 6. Monitoring and maintenance. Deployment is just the beginning. After your model is live, continuous monitoring is essential. Data distributions can change over time, a phenomenon known as concept drift, which can affect your model's performance. Set up monitoring tools to track key metrics like prediction accuracy, response time, and data health. If you notice a decline in performance, it may be time to retrain your model with new data or tweak your pre-processing and feature engineering steps. Automating this process can save you time and help maintain model performance. Tools and technologies. Throughout this workflow, we've mentioned several tools and technologies. Let's recap some of the most popular ones. Data ingestion, Apache Kafka, AWS Kinesis, Apache NiFi. Data preprocessing, Apache Spark, Pandas. Feature engineering, feature tools, custom Python scripts. Model training, scikit-learn, TensorFlow, PyTorch. Deployment, AWS SageMaker, Google Cloud AI Platform, Docker, Kubernetes. Monitoring, Prometheus, Grafana, custom dashboards. These tools not only help streamline your workflow but also allow for collaboration among team members, ensuring everyone is on the same page. Best practices. Now that we've covered the essential steps and tools, let's talk about some best practices to keep in mind when building an end-to-end automated AI workflow. 1. Start small, don't try to build a complex system all at once. Start with a small project and iterate. This allows you to learn and adjust as you go. 2. Documentation, keep thorough documentation of your processes, decisions, and code. This will be invaluable as your team grows or when you revisit the project in the future. 3. Version control, use Git or another version control system to manage your code. This helps track changes, collaborate with others, and revert to previous versions if needed. 4. Automate where possible, look for repetitive tasks that can be automated. This not only saves time but also minimizes human error. 5. Emphasize collaboration. AI projects often require input from various stakeholders, including data engineers, data scientists, and business users. Foster a collaborative environment to ensure diverse perspectives are considered. 6. Stay updated. The field of AI is rapidly evolving. Stay informed about the latest tools, techniques, and best practices by following reputable sources, attending conferences, and participating in online communities. Conclusion. In conclusion, building an end-to-end automated AI workflow for real-time data processing and insights is a complex but rewarding endeavor. By following the steps we've discussed: data ingestion, pre-processing, feature engineering, model training, deployment, and monitoring, you can create a robust system that delivers actionable insights in real time. As data continues to play a critical role in decision-making across industries, mastering these workflows will equip you with the skills needed to drive innovation in your organization. Thank you for joining us today. If you found this video informative, please give it a thumbs up, subscribe to our channel, and hit the notification bell to stay updated on our latest content. We'd love to hear your thoughts and questions in the comments below, so feel free to reach out. Until next time, keep exploring the exciting world of AI.